Hi guys, I'm doing this mostly for 8th period since I'm not going to be there, but this is available for you right now in Delta Math in case you weren't there, or in case you forget. If this is something you like, let me know and we'll continue making videos of the notes. So today we're talking about systems of linear inequalities. Yesterday we did linear equations. Today we're doing inequalities, so that means it does have a less than or greater than sign, or less than or equal to. So it's the solution of a linear inequality into variables like ax plus by equals c is an ordered pair which is in the form of xy that produces a true statement when the values of x and y are substituted into the inequality. So for example, we're going to prove algebraically that negative 7, 2 is part of the solution set of y is less than negative 1/3 x plus 5. Remember, this is your x, this is your y. So all I'm going to do is take my x and substitute for x right here, and take my y and substitute for the y over here. So that is 2 is less than or equal to negative 1/3, I forgot my fraction bar, parentheses, negative 7 plus 5. You go through and do your math. 2 is less than or equal to positive 7/3 plus 5, which I'm just doing mental math, would be 5 and 7/3, which we know 5 and 7/3 is in fact greater than 2. So this is why it is part of the solution set. So therefore, solution. On a graph, the solution set of a linear inequality is usually shaded. However, a solid, which we've also called a closed line, is also part of the solution set, while a dashed, which we called an open line, is not. The boundary line is dashed if you have a less than or a greater than sign, and solid if you have a less than or equal to or greater than or equal to. So we're going to graph the inequality y is less than or equal to, y is less than negative 1/3 x plus 5. This less than sign means one of two things. First, it's going to be an open line. And because y is less than x, it is going to be shaded below. From there, I know that my slope is negative 1/3, and my b is positive 5. So begin with b of 5, and then use negative 1/3 as your slope. So that's either up 1, left 3, or down 1, right 3. And we know my line has to be open. And I am shading below the line, so everything down here gets shaded. So I'm trying to prove that the point, I'm trying to find a different color, sorry. We're trying to prove the point negative 7, 2 is part of the solution set, meaning it's in the shaded area. So negative 7, which would be over here. Oops, I didn't realize my graph didn't go that way. And positive 2, which in fact is in the shaded area. Although it's not in the graph, if we were to continue my graph, that is shaded. So inside my foldable, the solution of a linear inequality is the ordered pair that is a solution to, this is supposed to say the solution of a linear inequality system. Is the ordered pair that is a solution to every inequality in the system. And on a graph, the solution set is, I had a lot of typos on this, is the intersection of the shaded areas. And usually only the solution set to the system is shaded. So it's going to be where they both intersect, and normally like on tests and stuff, they only shade that one part. So let's look at our examples. Example 1, y is greater than or equal to negative 2x. So first off, right off the bat, my sign, it's going to be a solid or closed line. And because it is y is greater than x, we are going to shade above. Next, my slope is negative 2. And my y-intercept here, notice there's nothing being added or subtracted. Nothing means 0. So your y-intercept is at 0. It begins at the origin. So here's my 0. And then I'm using my slope of negative 2 over 1. So up 2, left 1. Or down 2, right 1. My line is solid. And I am shading above. For my next inequality, here's my symbol, which means it's an open line, and it's y is less than. So we just have no x here, so y has to be less than 5. Because there is no x, y comes from the word hoid, which means we're going to have a horizontal line through 5. So that means we'll be shading under, since the less part would be underneath. So on 5, there we go. And it's an open line. So we are shading everything underneath. So the solution set is the intersection of both the shaded areas. So my intersection is just this area right here. Well, including up, but not the solid, or not the dashed line. So possible solutions here, we can have (3, 2). We can have 5, negative 3. We can have 2, negative 4. Non-solutions here is anything that is not in my shaded area or not on the solid line. So anything right here on the dash line or anything not in the double shaded area. So for example, negative 4, 1 can't be a solution. Yes, it's a solution to my y is less than 5, but not a solution to the system. The point right here, 0, 5, is not a solution. Again, yes, it's a solution to y is greater than or equal to negative 2x, but not to my system. It is on a dashed line, so it's not also a solution to this one, and it's not in this double shaded area. Another point that we could use would be up here, not even anywhere near any of the shaded areas, so negative 4, 6. Example 2. Y is less than or equal to 5 halves x. so we know it's going to be a closed line. And it's saying y is less than x, so we know we shade below. My slope is 5/2. My y-intercept, again, there is nothing being added or subtracted, so my y-intercept is 0, meaning it goes through the origin. Up 5, right 2, or down 5, left 2. It is a closed line. Next, my next inequality, oh, and I forgot to shade. Sorry. And we shade below. My next inequality is also closed, but we are not comparing an x to a y, or y to an x. This time it's just x to a regular number. There is no y, so we remember the word bucks, which means it's going to be a vertical line. So to show that x is less than, we're going to shade to the left. So on 3, on my x, and it is a closed line. And we shade to the left. So the double shaded area is this section right here. Alright, so notice now, both lines are solid, so where they end up intersecting up here will actually be a solution to the inequality. But I can't tell exactly what that's going to be, so I'm going to go ahead and just name solutions down here. So, for example, 1, -2 is a possible solution. The origin is a possible solution. And then we can also have some point up here. It's on the solid line. So 3, 3 is a possible solution. Non-solutions, again, anything not in this double shaded area. So it could be over here, -3, 3. 5, 0. Or even 6, 6. For these next couple of examples, we're going to try using Desmos to help us graph the line, just like we did on the notes yesterday. So notice this first one is good to go for putting into Desmos. The only difference is Desmos, we can't use this symbol. We have to use an equal sign. But we know what the symbol means. The symbol means it's going to be an open line. And y greater than x means it's going to be shaded above. So we'll come back to that in a little bit. For this one down here, though, we do have to solve for y to be able to put it into Desmos. So to solve for y, we first take away 6x. So we have 3y is less than -6x plus 9. And then we divide everything by 3. So y, -2x plus 3. Notice I didn't put my sign in. That's because I'm dealing with inequalities. So I always, always, always have to check. What did I divide by? I divided by a +3, which means my sign stays as it is. Does not change. So now that I have that information, I know that this is going to be open. And y less than x means you shade below. So again, if we have trouble graphing, Desmos to the rescue. I can bring it up here. I'm going to make it so you can see it. Alright, so I'm going to type in my first inequality, but again, remember you have to use an equal sign in order for it to graph correctly. And I take some points. -2, 0, 0, -4. This is for the first one, which is an open line. And shade above. My next line, we have y equals -2x. Again, I changed the inequality to an equal sign, otherwise Desmos will not understand it over here on this part. Y equals -2x plus 3. Oh, that was the blue one, so we're looking at the green one now. 0, 3. And 1.50. Let's find a prettier point. If I go to settings and bring up the table, that'll give me another point. -1.5, 1.1, and so forth. And then again, it's an open line. Notice my graphs are less than parallel, but they are supposed to be parallel according to Desmos. No difference. Open line, and we shade below. So the double shaded area becomes this area right here. Yes, they're parallel, but unlike equations, there is an intersection because it's two shaded parts that are intersecting each other. So possible solutions, we have the origin as a possible solution. We have -2, 2. We have 1, -3. I'm just choosing random points in that shaded area. Non-solutions would be everything in that non-double shaded area. So over here, even though it's a shaded part, it's not in the intersecting shaded area. So 4, 2. A non-solution can also be anywhere on the dashed line. So for example, this point right here, -2, 0 is not a solution. Or this point right here, 1, 1 is not a solution. It is on an open line, therefore not a solution. Example 4, we're going to use Desmos for that one as well. Notice none of these are set up to where y is by itself, so we have to do some manipulating of the equation, or inequality in this case. This one's pretty easy. All you have to do is take away 2x on both sides. And you have your new inequality. So y less than -2x minus 1. We didn't have to worry about the sign at all because I didn't divide by anything. So again, that means open. Y less than x means shade below. Okay. This one requires a little bit more brain power. You're going to start off by subtracting 4x on both sides. So we have negative 5y less than or equal to, I'm just putting the x in the front, plus 5. And now we need to divide by negative 5. I'm going to do some in a different color so y'all can see. Everything gets divided by negative 5, so we have y 4/5 x minus 1. But I divided, and it's an inequality, so I have to go back and check what did I divide by. I divided by a negative 5, so that means my sign must flip because it was divided by a negative 5. Okay. And now I can put this into Desmos after I figure out that it's going to be a closed line and that y greater than x means I'm going to shade above. So let's use our Desmos. First one is y equals negative 2x minus 1. And I'll bring up a table so it shows me some pretty points. And then you can click on them to see exactly where they're at. Negative 2, 3, negative 1, 1, 0, negative 1, 1, negative 3, 2, negative 5. It's going to be an open line. Assuming the next point's there. And I'm shading below. Very rough sketch. Alright, my next line, right over here, y greater than 4/5 x minus 1. So y equals 4/5 x minus 1. Again, I'll use the table to bring up some points, some pretty points. Not so pretty, not so pretty, pretty, not so pretty, not so pretty. So let's see if we get a pretty point if I go to 3, 4, 5. Finally gave me a pretty point. So 5, 3, and 0, negative 1. Zero, negative 1, 5, 3. And see in the other direction, negative 3, negative 4, negative 5, negative 5, negative 5, negative 5. And we have a closed line here. My lights just turned off. Hold on. There we go. And we are shading above. So the double area is right here. So possible solutions. Negative 2, 1 in the double shaded area. We could have negative 5, negative 5. It's on the solid line. And we'll do negative 4, 0. Alright, so now I want to go over a non-solution. This right here is not a solution. So 0, negative 1. And that's because although it is on a solid line here, this right here is a dashed line. So it is not a solution to both inequalities, just to one. Obviously for negative 2, it's nowhere in any shaded region. I wrote that wrong. For negative 2. And then we can pick a point up here. 2, 4. You'll see I still wrote that one. Alright. And for the final ones, which point would be a solution of a linear inequality shown below? They are already in slope-intercept form, so we can use Desmos to figure this out. All we're going to do over here is draw a quick sketch once we get it. So the first one, y equals 3/2 x plus 7. It's a line that looks something like this. We're at 7 up here, and like close to 5 over here, approximately. It's a quick sketch. And then we have y equals negative 1/2 x plus 7. Let me bring up the table for that one. So like negative 2.8, 0.7, 2.6. So something like this. This one, our first one that we did, and I probably should have done it in a different color. This one right here is shade above. And this one, and it is a closed line, and I got ahead of myself because this one is supposed to be an open line, but also above. So my line is open. Fix the little problem I made. Open line, and I shade above. So the double area is actually up here. And if I were trying to figure out which point goes up there, you can also use Desmos 0.7. We're going to label that point A, which is right there. So point A is the intersection point, which is not a solution because this line is open. So if I were to do my next point, 4, 9, and we're going to go ahead and label that one point B. Notice point B is over here. This was point A, which is not the double shaded area. My next point, 0, 10. I'm going to label that point C. And bingo, bingo, bingo. We found a point in the double shaded area. And just to be secure that I didn't do anything wrong earlier, point D is down here. Again, not in the shaded area. So C is the answer. Alright, let's try that again. Delete all. So my next one, again, quick sketch. This is solid below. This is open below. Y equals 5/4 x minus 3. So it's about negative 3 down here, and then something up there. And it is solid, and we're shading below. And my other line, y equals negative 3x plus 5. So they meet somewhere down here. I did it again. It's supposed to be an open line. And we are shading below. So my double area is down here. -4, -10. We'll label that point A. which is down here, which appears to be a good one, unless we did something wrong earlier. So let's go to a different point. Negative 8, 0. We'll label that point B, which is up here, which is not the double shaded area. Then down here, 0, 0, negative 10. Oh, see, we did something wrong. What did I do wrong? Oh, we didn't do anything wrong. It says which one is not. I didn't read. It says 0, negative 10. This B is a good one, so it might just be that one. And we'll see 4, negative 8. Label it D. Yep. So it's not any of these, it is B. Alright, I know that video was long. If you watched it all, thank you. Go ahead and glue this in your notebook and work on the rest of the Delta Math assignment. See you later!